Okay, so we are going to work on problem B here. In our notation, this is the probability of the union of A complement, B complement. So if A does not occur or B does not occur or neither occur, we're looking for the probability of that union of events. So what is A complement? It's anything outside of A, right? Including some parts of B that are outside of A, right? That's A complement. In fact, A complement, the probability of A complement alone is 1 minus the probability of A, right? So 1 minus 0.2 or 0.8. On the other hand, B complement, what's that? That's anything that lies outside of B, including some parts that are actually in A, right? So all of that stuff that's shaded is the union of A complement, B complement, right? A complement union, B complement. We know that this intersection, this piece, that the only part that wasn't shaded, we figured out that probability of that was 0.1 or 0.10. Notice we can think of this in two ways. I mean, we can see right away that the answer is going to be 0.90, but let's belabor it a little bit. We can notice that the probability of A complement union B complement is the same as the probability of the complement of A intersect B. Right, what I just described, it's everything outside of their intersection. And that's equal to 1 minus the probability of the intersection. Okay, or 1 minus 0.10 equals 0.90. What if we also note, we have some rules for unions, right? This is probability of, we can add A complement plus the probability of B complement minus the overlap probability of A complement, B complement. We could do that, but we might decide that, if we haven't figured out this already, in fact, that's going to be the next question, then this may just make things more complicated. So I would probably use the Venn diagram to figure it out, or write it out using the complement of A intersect B. This sort of relationship, we've seen this before. Well, actually, we'll see it again on these two relationships, the relationship between the union of A complement, B complement, and the fact that we can write probability of A complement union B complement as the probability of the complement of the intersection. This sort of back and forth, breaking it up, has a name. It's not in your book, but it's called De Morgan's laws. And you can, in just sort of thinking about it with a Venn diagram, you may be able to have it make sense going through that yourself. We'll do this now again with C, where we're looking for the probability of A complement intersect B complement. And here's that diagram again. Here's A and B. And let's think about it with the diagram. Okay, where is A complement? Just as we did before, we're talking about A complement and B complement, but this time instead of their union, we're taking their intersection, right? So, if this is, I could have just left the graph since it's really the same graph. Here's A complement, and here is B complement is anything that's outside of B. I went a little bit inside. I don't want that. And we've got the outside of B complement. So what is it that's A complement intersect B complement? Sorry, quick distraction. So A complement intersect B complement. Where did those overlap? Well, everywhere that is inside neither of them, right? So it is. Actually, let's make this nice and big. Right here is A complement intersect B complement is anywhere where both where A does not happen and B does not happen, right? So that is also can be seen as the probability of the complement of their unions. Do you see that? Their union is everything inside the circles. Anything that's A or B or both. And so anything that's not anywhere in A or in B, right, is the complement of A union B. And that's the same thing as the overlap between not A and not B. Okay, well, that's good. Once we see that, we've really got our answer, because we have that the union of A and B, right? We had the probability of A union B is 0.4, and so the probability of the complement A union B is 1 minus the probability of A union B, and that's 1 minus 0.4 or 0.6. Yeah. Okay, we got one more. Let's see if we can get this squeezed in. This is a little trickier, maybe. I don't know. See what you think. So D is the probability of A complement given B. So let's think about how we would solve this. We can do it with the axiom 4 about that really defines what a conditional probability is. And let's also keep an eye on the Venn diagram. So just in terms of, it might not be helpful other than to remind you what the rule is for calculating a conditional probability of events that are non-zero probability. But given that B is true, right? So given that we're, let's do blue. Given that we're somewhere in circle B, what is the probability that we're not in A? Right? So given that we're somewhere in B, what's the probability that we are not in A? So we're confining our attention to that part of B which is not in A. And so it's that fraction, it's that not B, right? It's the not A part of B divided by B, because we're somewhere in B. Okay, if that is not helpful to you, and I imagine it might not be, let's just write it out using the rule that says, okay, the probability of something given something else is the probability of their intersection, A complement intersect B, divided by what? Divided by whatever you're conditioning on, right? Whatever we're restricting our attention to, we're somewhere in B, and we're in the part of B that is not in A. Can we do it? Well, we know the denominator already is 0.3. That's good. Right, we know that denominator is 0.3. Incidentally, what's the numerator just going based on intuition? Well, if the whole of b has a probability of 0.3, and we've seen in an earlier stage that the part we're leaving out, a intersect b, that's 0.10. And so the numerator is going to have to be 0.2, right? If you want to calculate it, we can go further. We can think about this as the probability of a complement times the probability of b given a complement, or we can think about the probability of b times the probability of a complement given b. But I'm not going to go through that there. I think that the way we looked at it is probably the simplest, and really what it's based on is the fact that, again, I used this trick before. We know that there's the axiom 3 gives us that a rule for unions, and we can apply it here if we had wanted to. Right, we know that for a union, probability of a complement union b would be equal to probability of a complement plus probability of b minus the probability of a complement intersect b. And so here, if what we want is this, and we know this, and we can also get a probability of a complement union b rather easily, we can solve for this. But here is one of those places where I think looking at the Venn diagram makes it easier, recognizing that the denominator is probability of b, that's 0.3, and the numerator is the probability of a complement and b. And where's the a complement and b? That's the part that I shaded in black. And that has to be the 0.3 minus the gray spot that was the intersection of a and b. Okay, that is a pretty tricky one. Congratulations if you stuck with it. And if you had trouble, try waiting 10 minutes and go again once you've forgotten my explanations, and see if you can piece it together. Okay.